Hello everybody, welcome. Today I want to talk about the first conic section, which would be circles. So please get yourself some paper and some pencil, and also maybe a compass and some graph paper, because we're going to be doing some thinking, and when you're thinking you should be writing, because those two go best when they go together. Now, circles are the first conic section, but most textbooks don't do circles first. They will do parabolas first. And I don't agree with that. The reason why I think they do parabolas first is because the equation that you use for a parabola, when it's simplified, is simpler than that of a circle. It's only got one squared variable, whereas a circle has two. But the way that you get the formula or the equation for a parabola is really complicated, and in terms of the definition of what a parabola is, it's more complicated. And so I would rather start with the simpler ideas and build upon those, even if we have to do a little more complicated mathematics in the meantime, so that you understand what it is and what it means. I don't want you to be just a mindless computational tool. I want you to understand the meaning behind it, and so the circle is the simplest one. So let's switch over now and talk about circles. Okay, so the definition of a circle from geometry is it's the collection of all points equidistant from a fixed point, and that fixed point, then we call that the center. But now let's do a bit of review. Before we talked about circles, we talked about points. Remember, a point on a Cartesian coordinate grid or a rectangular grid, which was the space invented by René Descartes, so it's called a Cartesian coordinate grid. The point is the ordered pair, an x and a y. And then the distance, remember the distance formula? The distance formula was the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. But actually that came out of the Pythagorean theorem, as we've seen earlier, but it was still just c squared is equal to a squared plus b squared. Okay? So with that being reviewed, now that we've got points and then we've got a way to find the distance, let's go back and look at the definition of a circle. It's the collection of all what? Of all points. So we had to have this already established. The ordered pair was a prerequisite for doing circles. The collection of all points equidistant. So we had to have the distance already established. And so naturally then, as you can maybe see, the circle comes next. So let's take a look at a circle. This is one of the that I drew when we were doing the introduction to conics. And so let's just take a look now at this circle and see if we can sort out some of the details. All right, so let me get my pen going here. I want to change the thickness. And so what I want to do is this. I want to know what's the distance between the center and this point over here on the circle. In fact, that's not even quite thick enough. Let me thicken that up a little bit. Well, maybe that's a little better. What's that distance? Well, as you can imagine, what we're going to do is we're going to take and make a little right triangle here. So what I'm going to do is I'm going to come across here to right there, and then I'm going to come down here like this, and then I've got a little right triangle right there, and then I want to know this distance right here, and I need to find the lengths of the sides. So let's see, the bottom side is 1, 2, 3, 4, 5, 6, 7 units long, and the right hand side is 1, 2, 3, 4, 5, 6 units long. So from the Pythagorean theorem, c squared is equal to a squared plus b squared. Okay, now I can say, well, this is now going to be distance squared is equal to 7 squared plus 6 squared. So the distance squared is equal to 49 plus 36. The distance squared then is equal to, what is that, 70 plus 15, 85. And so then we take the square root of both sides and I say distance is equal to then the square root of 85. Okay, nice. Well, that's review. But here's the thing. Every single point on the circle is the same distance from that center. So let me do another triangle. Let me erase this one. I may have to come back to that later, but let me erase that one. And let me do another one, and let me do this one, let's say in blue. I want to go to, from the center to that point right there. Can I do that? There we go. Okay, because there's a point on the circle right here. Now, how long are the sides of this right triangle? Well, if I do a side right there, and I then go to that side right there, there's my right angle. I want to know this distance. Well, it should be the same, right? Shouldn't this be the square root of 85? Well, let's find out. So the side length on the right-hand side, if you can see that, that's 2 units. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 units along that one. So the same thing here. C squared is equal to A squared plus B squared. And so then D squared is equal to, what do we got? We got 9 squared plus 2 squared. D squared is equal to 81 plus 4. Oh my goodness. D squared is equal to 85. It's the same thing. Okay? And that would work then for any point on the circle. The distance is always going to be the same. And of course we know that that distance has a special name. It's called a radius. It works for any point on the graph. Let me get rid of some of the clutter here. And it'll work for this point right here in red. But I want you to notice that that does not give integer values for the length and the width. That point's going to be some fractional thing. But the distance is still going to be the square root of 85. Okay, so now let's do a Cartesian adjustment. Let me go back to the first point that I did and let me make a bit of a change. Let me now add in an x and a y axis and we'll see what that does now. So let's see here. I'm just going to kind of guess. Let me make this line right here my y-axis. That's y. Let me make this line right there my x-axis. And so there's my origin right there. All right, so now what do I have? Now I can actually assign ordered pair of coordinates to these 2 points, the center and then this point over here that we started with originally. This point is going to be, the center is going to be 3, 2. And this point over here, let me count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This point is going to be 10, and then up 1, 2, 3, 4, 5, 6, 7, 8. Here we go. Okay. Now again, what's the distance between those 2 things? Well, let me use the distance formula, and it's going to be distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, this is nothing other than saying c is equal to the square root of a squared plus b squared. So again, it's the Pythagorean theorem, right? It always comes back to that. But now let me substitute the numbers in. So now the distance is equal to the square root of, well, what was the second x value? That would be 10 minus the first x value. That would be 3 squared plus the second y value, which is 8, minus the first y value, which is 2 squared. And so I get distance is equal to The square root of 10 minus 3, isn't that 7 squared? And then plus 8 minus 2, isn't that 6 squared? Isn't this what we had to begin with, right? 49 plus 36. Pull out my machine. I'm just double checking. 49 plus 36. 85. Oh my goodness. The distance is equal to the square root of 85. Same thing. But now we did it with Cartesian points. Okay, did you follow that? It's the exact same thing, except now we're using Cartesian points to figure out what the length of the x and the y of that right triangle are. But now here's the deal. We want to now generalize so that it can be used for any center and any point on the graph. It can be used over here for an x and a y over there. And it can be used, say, over here for an x and a y value there. So here's what I'm going to do. I'm going to now replace the center with some letters that were represented, like variables, although they mean not things that change. They mean specific values. I'm going to replace the center with h and k. H represents the x value of the center, and k represents the y value of the center. And I'm going to replace 10 and 8 over here with just the generic x and a y. That means some x and some y that's on the graph anywhere. But the center is fixed, right? That center can't change. It's h and k. Let me go back up here now, and I'm going to now change the formula from that point on right there. And this is where it gets really good. Okay, the distance now is equal to the square root of the second x, which was just the x from right here, minus the first x. Well, the first x was the center, h squared, plus the second y value, which is just the y from that point, y, minus the y value of the center, k squared. Almost done. What do we call the distance between the center and any point on the circle? It's not just a generic distance, it's a special name. Isn't that the radius? So let me replace d with r. One more step. Square both sides. R squared is equal to x minus h squared plus y minus k squared. There you go. That is the equation in standard form for a circle. You should memorize that. The center is the point h, k. Notice the negative signs in there. It's x minus the h, and it's y minus the k. So like a parabola, you have to do the opposite of the sign that you see in the equation. And the radius is r. Actually, don't forget where it comes from. It comes from c squared is equal to a squared plus b squared. Because in the end, yeah, what I've got is I've got just a right triangle in there, right? Okay, it's all based upon the Pythagorean theorem. All right, so now let's talk about how to graph something if you're given an equation. Let me do this. Let me graph the following, and I'll do it on graph paper, you'll see. Graph the equation now, x minus 3 squared plus y plus 2 squared is equal to 49. Above, I wrote it with r first in the box there because mainly I want to focus on the hypotenuse, just like I did with the Pythagorean theorem. But most of the time you'll see it with the x's and y's on the left side of the equal sign and your radius squared. 49 is not the radius is 7. Okay, you'll see it with the radius squared on the right hand side. So what do I need? I need a center and I need a radius. The radius is easy, 7. What's the center? It's an ordered pair. It's going to be 3, negative 2, right? Because you go by its x minus the h, and so the h is positive 3 in this case. All right, so 3, negative 2. Let me do a little switcheroo. Hey, that rhymed. Okay, here's my Cartesian coordinate grid. And so what do I need to do first? Let me first plot the center. Center is 3, negative 2. So I'm going to come over here, 1, 2, 3, down 2. Here's my center. And then the radius is going to be 7. Now when you draw a radius, I recommend that you either go left, right, or up, down. Don't try to draw a catty corner radius or a diagonal radius. Just, this is the center right here. And then I'm going to count 7 units to the right. So 1, 2, 3, 4, 5, 6, 7. It's going to be this point right here. Okay, now, this is my compass. This compass allows me to actually draw a circle nice and neat. Now, you probably didn't use this kind of a compass in geometry class if you've had geometry class. I'm going to show you several compasses now that are good compasses, and then I'll show you one that's bad. Chances are you probably have the bad one, and when I explain it, you'll be like, oh yeah, I understand why that's bad. So this one's fine. I'll show you how to use this one in a minute. This one's really neat. This one is kind of a similar compass to the one I just showed you, but most of the time you're looking at something like this. This one's good. It's got a little adjustable tension screw with a nut right here that will allow you to fix it and have it stay tight on you while you draw your circle and not slip. Slipping is bad. How many of you ever drawn a compass with one of those things and you tried to go around and it opened up on you or it closed on you? But most of the time it's opened up on you, it slipped, and you're like, whoa, and then ripped a hole in the paper. So that one is fine. This one is fine because it's got this adjustable thing here that's held under spring tension. This one's actually a little bit better because you can adjust this nut right here to have it only open as far as you want. And then you can, you know, do your little compassy thing with that there. This one, like, is if you own one of these, you are a serious student of mathematics, right? These are the tools. These are the tools of your trade. So just like a carpenter would have a saw and a hammer and nails, and not just cheap junk, but stuff that he would actually do good work with. Sometimes not having a good tool means it's impossible to do a good job. Or a surgeon. Surgeon's got to have his tools and stuff like that and have them ready to go and good. And you want the surgeon to have good tools. You don't want the surgeon to have a dull scalpel. Dull scalpels are dangerous. Yeah, here. Let me show you this. This is the kind that you should not get. That's trash. And I have to tell you, I'm laughing because I looked all over my house today to find one of these to actually show you like I did all the other ones, but I don't own any. Like, I purged my house of all of these horrible, trashy junk compasses, and I don't have any more. So, anyway, back to this now. All right, so this one's the best. I'm going to have to get over here and really kind of take a look at this, so pardon me. Here's my center. The center on this one goes right in that little brass ring. And so I put the center of the circle right in the brass ring. I hope you can see the pencil mark. And then if I put my finger here, this will spin, see? And so what I do is I find the little hole on the compass. No, I'm looking for, see this? I want it to come out to here. This is my radius right there, 7. So what I want to do is I want to find the hole in this little list of holes up on top, which are measured for if you want specific distances, or down in the bottom. Okay, and it looks like this one right here is the best one. And so I will then just spin it around. Voila! There's my circle. Okay, I need to check the radii. Did it slip at all? I don't know. If I go up, I should have 7. 1, 2, 3, 4, 5, 6, 7. Nope, I'm in there. And then down. 1, 2, 3, 4, 5, 6, 7. Okay, and then left. 1, 2, 3, 4, 5, 6, 7. I'm in. Okay, so now what this is the equation now of this circle is going to be x minus 3 squared plus y minus 2 squared is equal to 49. And so what this means is any point that I pick on the graph of the circle, like this point right here, what is that order pair? That looks like it's 1, 2, 3, 4, 5, 6, 7, 8. This looks like it's the point 8. And then up 1, 2, 3. This looks like it's 8, 3. Does 8, 3 satisfy this equation if I substitute it in? I mean, you could do the math and check right there. It looks like it's close, but it might not be exactly. Looks like it's maybe under that grid line a little bit, and maybe there's just a little bit of human error when I did this circle. But this should be the equation then that satisfies any point on the circle, any single one, anywhere. The center is not the circle. It's this that's the circle. And remember what the graph of an equation is. The graph of an equation is the collection of all solution points. So if your circle is warped or twisted or bent or sloppy or otherwise not beautiful, you have not drawn a true circle. Truth and beauty in this case go together. So if you're drawing it by hand, how would you draw it by hand? Well, if you're drawing it by hand, if you don't have a compass, I would plot the center and then plot left a bit and then plot up for my my other point, my radius, and then go 7 to the left and then go 7 down. And then I would very carefully, as best as I could, connect these with smooth circles. And you're going to have to maybe erase it, but if it looks warped and bent and twisted, don't be satisfied with that, right? Your teacher should not be satisfied with that. If you submit ugly or not excellent circles, you should not expect excellent marks for your grade, right? So the circle needs to be true. And when the circle is true, it's beautiful, okay? And so we should pursue truth and know the truth, because if we know the truth sets us free. So anyway, practice it. Sometimes it's actually easier if you're doing it with one of these compasses to here, I'll just show you. To set it up, set your compass up, and then instead of spinning your compass like you ordinarily would, sometimes it's easier to hold the compass at a bit of an angle and then just spin the paper, right? Sometimes that's a little easier to do. So anyway, moving back over now, let's discuss some more. What happens now if we are given some things and we need to write an equation? So let me make some space here. What happens if I say that, I don't know, I have a circle whose center is at -7, 9, and the radius is 11. How do I write an equation for that circle? Well, remember the formula. It's going to be x minus h squared plus y minus k squared is equal to r squared. And then we just substitute the pieces in. It's going to be x minus a -7. Did you see how I switched it? A minus and negative as a positive. X minus a -7 squared, don't forget the squared, plus y minus 9 squared is equal to 121. Here we go. That's really fairly easy. Okay. How do you write an equation from a graph, though? Where's my graph? Here we go. What do we need? We need a center, and we need a radius. The center is easy. It's this point right here, and I tell you it's -1, 4. So the center is -1, 4. But the radius is not so easy. How do you find radius? Well, I know a point on the circle. Can't I then use the Pythagorean theorem or the distance formula to find that distance between those 2 points? Yeah. Sometimes you can maybe just kind of come over and count left or right and find the exact point, but this one's not the case. They actually just give you a point on the circle. So I'm going to have to use now the distance formula to find this. So the distance, where's my pen? Here we go. Distance is the square root of, and I always write the formula down every time I use it, x2 minus x1 squared plus y2 minus y1 squared. Now the distance, which is also the radius, remember, is equal to the square root of, I don't know, I'll pick the center as the first point. So this is point number 1 and this is point number 2. It doesn't make any difference because even if you wind up with a negative change, you're going to square it anyway. So you won't have a negative value that'll mess anything up. So let's see here. X2 would be -4 minus a -1 squared plus the second y value, which is 6, minus the first y value, which is 4 squared. I think that's right. So distance is equal to now the square root of negative 4 minus 1. That's negative 3 squared. Isn't that 9? Plus 6 minus 4. Isn't that 2 squared? That's 4. And so now I get a d, the distance there is what? The square root of 13? Okay. But now the radius then, square root of 13. But remember the formula for a circle. It's going to be x minus h squared plus y minus k squared is equal to r squared. So now I just put the pieces in. X minus a negative 1 squared plus y minus 4 is equal to 13. Here's my answer. Okay? Pretty nice. One more. This is the one that y'all have been waiting for because it's hard. Write the equation of this one in standard form. X squared plus y squared minus 8x plus 12y minus 12 is equal to 0. Oh my goodness. I've got to get it. I've got to get it in this form right here, which means I'm going to have to complete the square, not just with the x, but also with the y. Okay. Oh, side note, before I forget. Your coefficients on x squared and y squared always have to be 1 with circles. That'll be different later on, but they've got to be 1 with circles. So if you come across an equation that had some number out in front of x squared, like, I don't know, 5x squared or something like that, you would have to divide everything through by 5 to get that coefficient of 1. So be mindful of that. But anyway, so here's what I'm going to do. I'm going to do a group of x's. I want to take x squared and negative 8x and put them together. So I need to do now a group of x squared and then minus 8x and then leave space plus, and now I'm going to group the y's. Y squared plus 12y, leave space. And now I'm going to take this negative 12 and pass it to the other side of the equation by adding them. So this is equal to positive 12. Okay, there we go. Now I've got it set up to complete the square twice, once for the x group and once for the y group. But remember that whatever you do to one side of the equation, you must do to the entire other side. Y dot c what about toss? And now we can do it with other sides because I do have an equal sign there. So let me complete the square with the x. I will say that that's going to be then half of 8 is 4 square that. I need to add 16 on the left in the group, but then I need to add 16 on the right. And this one now is going to be half of 12, which is 6. Square that, plus 36. So plus 36 on the left, plus 36 on the right. This now factors down to something squared. X minus 4 squared. Plus, this factors down to something squared. Y plus 6 squared is equal to 12 plus 16 plus 36. 12 and 16, 20 plus 28. 28 plus 36. 64. How nice. Okay, good. So there it is in standard form. And if you wanted to, the center is going to be at 4, negative 6. And the radius is going to be the square root of 64, radius of 8. Okay? Circles are fun. What else can I say about circles? I like them. Circles are interesting. When you're talking about, say, like the area coverage of a radio broadcast station or something like that, it's a circle. If you're talking about the area covered by a spotlight, it's a circle. Things like that. So anyway, I hope you're having a great day, and let us continue to pursue goodness, truth, and beauty. Bye-bye.